Good morning. This is your stats sensei, Mr. Spensei, and this is semester review, and this is going to be problems 1 through 25. At least I hope it will be. So the average noise level is a bar is 36 in a bar is 36 decibels with a standard deviation of 5 decibels. So they're telling us right here is like, oh, we have an average, so that means we have a mean, and the mean is 36, and we have a standard deviation of 5. With that said, assuming a normal distribution, what's the probability the noise level is between 30 and 40? So we're going to go, okay, we're going to go a little bit below and a little bit above. So we're looking for this area. Well, anytime we are looking for a probability, if we're looking for an area percent or probability, and we're talking about a normal, we're going to use a normal CDF. So norm CDF, lower is 30, upper in this case is 40, mean a 36, and they told us the standard deviation was 5. So that's where I'm going to go on the calculator. So second vars, normal CDF, lower 30, upper 40, mean of 36, standard deviation of 5. And we're about approximately 0.6730. So 0.6730 is going to be my best number. That looks like that one's D. On number 2, the SAT scores for applicants to a particular engineering school are normally distributed, okay, with a mean of 680 and a standard deviation of 5. What percentage have below a 750? All right, so again, we're working with a normal, and we have a mean of 650, or excuse me, a mean of 680. Standard deviation over here is 35. And we want to know what percent are below 750. Again, because we're looking for a percentage, anytime you're looking for an app, if you look for an area, percentage, or probability, if you're looking for it, it's a norm CDF. So norm CDF. In this case, our lower is going to be negative infinity. Our upper will be 750. Our mean will be 680. And our standard deviation will be 35. Second vars, norm CDF, lower, negative 9.99, upper, 750, mean of 680, 680, and a standard deviation of 35. And we end up getting 0.977%, or 97.97%. Right? It looks like E for that one. The mean income, household income in a certain state is 28,000 with a standard deviation of 8,500. So, once again, we have a mean of 28,000. We have a standard deviation of 8,500. We want to know they have 95% have a value above what? Now, we have to be careful with this. This is a tricky question. So first off, they're asking you for, they're giving you the percent. If they give you that, you're going to use an inverse norm. If they give you an area percent of probability, use inverse norm. And I'm going to draw an X, and the 95 is over it. So that means I'm going shading up, and this area right here is 0.95. So that means this area over here is just 0.05. So I need to do an inverse norm. And the very first thing it's going to ask me for is my area. My area in this case is 0.05. My mean is going to be 28,000. And my standard deviation is 8,000. 500. Now, if they'd been asking for a z-score, I would have used inverse norm, but they were just asking for the value. So second bars, inverse norm, area, 0.05, mean, 28,123, 8,500. We always work at the left. And we get $14,018. So the closest one to $14,018 is letter C, which is at 14,000. All right, number 4. A machine produces electrical components. 99.7% of the components have lengths between 1.176 and 1.2224. Assuming the data is normally distributed, what are the mean and standard deviation? All right, so first off, they're telling us this is normal. So our mean is going to be in the center. And we'll have 1, 2, 3 standard deviations this way and 1, 2, 3 standard deviations that way. And they're telling us that 99.7% are between 1.176 on the low side and 1.11 or 1.224 on the high side. Well, if I average those two together, if I just add those two together and divide by 2, in other words, if I take the average of the two, I'm going to get my mean. So that's the easy part. So let's go ahead and do that. So 1.176 plus 1.224. It's only two values, so I need to divide by 2, and I get 1.2. Well, right there, that tells me my mean is 1.2. Well, these look like those are going to be my closest to being correct. Now, my standard deviation, we're going to have 3 standard deviations above and 3 standard deviations below. So let's take let's subtract those two. It doesn't matter what you subtract, but 1.224 minus 1.2. And it's like, okay, that's 3 standard deviations. So if I divide it by 3, it's like, oh, 0.008. That tells me real quickly that my answer is D. On the other hand, I could have taken 1.2 minus 1.176 and divided by 3, and I still would have gotten 0.008. Or we can remember that there's plus or minus 3 standard deviations above and below, which means 1, 2, 3, 4, 5, 6. I could have gone 1.224 minus 1.176 and divide that answer by 6 and still get 0.008. So either way, any way of the 3 ways, I could have gotten 0.008. We've averaged these two together to get the 1.2, and that gives us answer D as our answer choice. All right, moving right along. Number 5, the tea company, the Fresha Tea Company, packed tea bags in marked as 250 grams. A large number of packs of tea were weighed, and the mean and standard deviation were calculated as 255 and 2.5 grams, respectively. All right. So once again, they have 255 is our mean. Our standard deviation is 2.5. They're telling us normally distributed, and the bags are marked as 250. So we want to know what percent are below that. All right, we're not caring about what's above it. Well, remember, it's normal, so go to a normal CDF because they're asking us for the percentage. They're asking us for an app, and if they ask for an app, norm CDF. So norm CDF, lower negative infinity, upper 250, mean 255, standard deviation 2.5. So here we go. Second vars, norm CDF, -9, -9, caret 99, upper 250, mean 255, standard deviation 2.5. And I get 0.0227. Well, the one that's closest is letter A. All right. The ages of the population of a town are normally distributed with a mean of 43 and a standard deviation. The town has a population. How many would you expect to be 22 and 57? Well, this is a little bit tricky. So first off, let's go ahead and make our graph. And we know we have a mean of 43, standard deviation 14, and we want to be between 22 and 57. So we're going to use a norm CDF. So let's do that first. Norm CDF, lower is 22, upper is 57, mean is 43, and standard deviation is 14. Now, when I do this, I'm going to get a probability. So I'm not going to be done yet, but I'll be well on my way. So second var is norm CDF, lower 22, upper 57, mean of 43, standard deviation of 14. All right, so I end up getting 0.7745. I'll come back to that in just a moment. One thing we have to remember is expected value is n times p. In other words, the sample size, which happens to be 5,000, times that probability that we got of 0.7745. So let's multiply that by 5,000. And we get 3872. And the answer that's closest to 3872 is letter C of 3870. All right, moving along. Which of the following is the best estimate of the standard deviation of the distribution shown in the figure? Well, first off, what we know about the figure? Well, we see that the mean is 50. And we see that it looks like it's normal. So this looks like it's normal. And if we know it's normal, we should have plus or minus 3 standard deviations above and below. So 1, 2, oh, there should be another one up here. So this is probably 80. And this is probably 20 down here. So how much difference is there between each one? And it's like, oh, each one is changing by 10. My standard deviation must be 10. If you wanted to be complicated, you could go 80 minus 20 and get 60 and go, well, plus or minus 3. So that means 1, 2, 3, 4, 5, 6. And if I took that 60 that we just found, the difference, divided by 6, we get 10 as well. All right. Students pass a test if they score 50% or more. The marks of a large number of students were sampled and the mean and standard deviation were calculated as 42% and 8%. Assuming the data is normally distributed, what percentage pass the test? All right, so they're giving us a mean of 0.42, a standard deviation of 0.08. And they pass if they make a 0.50 or greater. So once again, norm CDF, lower is 0.50, upper, positive infinity, mean 0.42, standard deviation 0.08. So second vars, norm CDF, 0.5, 9,99, 9,99, 0.42, 0.08, and we end up getting 0.1586. So our closest answer is letter B, which is about 16%. All right. Not that we're going particularly slow, but I hope these will be even faster for this next for the next several. All right. Well, I say that it'd be nice if I were set up for it, but I guess I'm not. So we'll do the best we can. All right. So looking at the computer printout, what is the coefficient of determination? Well, when they're asking for the coefficient of determination, they're looking for r squared. So in this case, that's very easy. Our r squared happens to be 76%. So D. The next one. For the computer printout above, what is the standard deviation for the residuals? So they're asking just for S. Our standard deviation of residuals is 0.05658. So that's letter C. Then it says for the computer printout above, what is the slope of the regression line? And let's look at that real quickly. The key word is constant. That's our y-intercept. This is our slope row. So in this case, our slope is negative 2.755. And I really thought I had something for me to use to help make this go a little bit better, but apparently I've misplaced it. So we'll just continue the way we are. All right. For the computer printout above, what is the coefficient of correlation? Now we have to be careful here. Coefficient of correlation is the sine of the slope and then the square root of r squared. Well, in this case, our slope was negative. We had a negative slope, so we're going to need a negative here. And our r squared was 76%. So negative square root of 0.76. I don't like using the square roots key, so here we go. 0.76 raised to the half power. So negative 0.8717. Be careful, this one is positive. Can't be this one, it has to be this one here. For the computer printout above, what is the y-intercept? So they're asking for the y-intercept, they're asking for the constant. So I need to look at the constant row, and my constant in this one is 23.514, which happens to be plain old letter A. All right, so that one pretty quickly. Next one. For the computer printout above, what is the coefficient of determination? Once again, we're asking for r squared. All right, r squared is 70.03. So letter D. If it's given as r squared adjusted, it's not that. What is the standard deviation of the residuals? S is the standard deviation of the residuals, which in this case is 0.8408. What is the slope? Well, remember, this is the y-intercept row, and we know that because it says constant, so that's the y-intercept. This is my slope row. So my slope is negative 3.485. For the computer printer out above, what is the coefficient of correlation? Remember, it's going to be sine of the slope and then a square root of r squared. Well, what was our slope? Our slope was negative, so we'll have a negative r squared. And when we look up, r squared is 70.3. So negative square root of 0.703. So again, I don't like using a square root sign, so 0.703 raised to the half power. And it's negative. All right. So in this case, make sure that you choose the one that's negative, because that one's positive, so it's the negative one. All right. For the computer printout above, what is the y-intercept? Well, y-intercept is on the constant line. And on our constant line, we have 24.2. So 24.2 happens to be my y-intercept. All right, that takes care of that one. Number 19. For the computer printout above, what is the coefficient of determination? Once again, coefficient of determination is r squared. It's never used the adjusted. So in this case, it's just 0.873. So letter B. For the computer input above, what is the standard deviation of the residuals? They're asking for S, so 0.237. For the computer printout above, what is the slope of the regression line? So they're looking for, remember this is the y-intercept. This is my slope row. So my slope is 0.240. What is the coefficient of correlation? Well, remember, sine of the slope and the square root of r squared. Well, in this case, my slope was positive. All right, so this is a positive slope. So I'm going to have a positive in front of my r squared, and my r squared is 0.873. So it's going to be a positive square root of 0.873. 0.873 raised to the half power. Oops. 0.873 raised to the half power. And we get 0.9343. And remember that this time we are positive. We don't want the negative one, but our slope is positive. So our correlation is positive. For the computer printout above, what is the y-intercept of the regression line? Remember, the constant is the key word, and constant gives us our y-intercept row. So our coefficient is 0.137, and that would be our answer, which happens to be, on this case, letter E. All right. 24 through 26, and that'll be the end of this video. For the normal curve above, what percentage fall between -5 and 13? Well, I'm sorry. I'm looking at 25. I should be looking at 24. For the normal curve above, what percentage of values fall between 65 and 75? Well, first off, we can identify that 70 is our mean. We have 3 standard deviations below, 1, 2, 3, and 3 standard deviations above. So in this case, my mean is 70 and my standard deviation is 5. Now I could do a norm CDF, but remember, this is 68%. This is 95%. And this is 99.7. So we want to know the between 65 and 75. So 65 and 75 right here is just plain old 68%. All right. So that one was pretty easy. For number 25, for the normal curve, what fall between -5 and 13? Well, once again, we identify our mean, and our mean in this case is 4. And we're changing by 3. So our standard deviation happens to be 3. And because we're just using the empirical rule right here, there's the 68%. That's 95%. And this right here amounts to 99.7%. And we're looking for the 5 to 13. So our answer choice is E. The next one, for the normal curve above, what percentage of values fall between 30 and 58? Well, once again, we have a mean right here. So our mean is 44. And are changing by 7. So that means our standard deviation is 7. And I could do a norm CDF and calculate the areas, but this is just a simple case of working with the empirical rule. So remember this right here, 68%. This is 95%. And then right here we have 99.7%. But we're looking for the 30 to 58. And so that follows the 95% rule, plus or minus 95, plus or minus 2 standard deviations. Because 1, 2 below and 2 above, that's the plus or minus 2. Up here we had plus or minus 1. Here we had plus or minus 3. All right, so this is your Stat Sensei. This is problems 1 through 26. And I hope you'll join me for the next one. Next 2 videos will be a bit longer. Thank you.